Hello friends and welcome to a lecture on operation research. Today we will study about replacement models, and these replacement models have a time value for money. This is Professor Arvind Prasad. Let's say I is the market interest rate on an investment. Therefore, rupee 1 invested today is 1 plus I the whole raised to n after n years. And let us say if we earn rupee 1 after n years. Let's take today as 0 years and let's take n as 10 years. Now 10 years hence, if we earn rupee 1, its value today is going to be 1 plus I the whole raised to minus n today. Now let's further explore this. Before that, new is going to be 1 over 1 plus I. This is also known as the discount rate. So let's take an example to understand what we see in the last slide. Let's say we have rupees 100 today, that is in 2022. Its worth is going to be 100 into 1 plus 0.07, that is 7% interest, the whole raised to 10. That's 196.71 rupees. That is rupees 100 today. If it earns an interest, a compound interest of 7% yearly, it's going to be 196.71 at the end of 10 years, that is in 2032. Similarly, rupees 100 today in 2022 will be 100 into 1 plus 0.07, that is the interest rate today, raised to minus 10, that is 50.83 rupees 10 years before, that is in 2012. Let's say for any machine, C is the purchase cost, RI is the annual running cost in any year I. The present value of investment on the machine is going to be Pn is equal to C plus R1 plus new R2 plus new square R3. That is, we discount the annual running costs to year 0. Therefore, C plus R1 plus new, which is nothing but 1 over 1 plus I. And similarly, we discount it every year to the present value of investment. So Pn is the amount required now, that is today. Supposing now in this last example, let's elaborate a bit. Pn is going to be the present worth or the present money today I should have in case I'm going to buy a machine which is at cost C and which is going to have a cost of R1 as the annual running cost in the year 1. R2 is the annual running cost in the year 2. R3 is annual running cost in the year 3. So Pn is the total amount I should be having today. So it is the amount that I require now to pay for all the future costs of acquiring and operating the machine, assuming that the replacement is in n years. Let's assume that Pn is an amount that I have loaned to meet all this capital and running costs. And let us say X is the amount I pay at the end of each year towards the loan. So Pn is going to be equal to C plus X plus new square X plus new till new n minus 1 X. The idea of calculating Pn is same as in the last slide. That is, we discount all the future loan installments to the present year. Therefore, X is equal to 1 minus new over 1 minus mu the whole raised to n into Pn. And further from this we get that if the running cost in any year n plus 1 is greater than what you see on your RHS is nothing but the weighted average annual cost. Okay, this is known as the weighted average annual costs. So if the weighted average cost is less than the running cost in the subsequent year, then we have to replace it. Or let us see the other way. If the running cost in the subsequent year is higher than the weighted average cost in any year, then it's a good idea to replace the equipment. Let's take an example and understand it. A machine costs 500 rupees. The operation and maintenance cost for the first year is 0. Thereafter, it increases by rupees 100 each year. If the average return rate for investment in financial instruments is 5%, when should the machine be replaced? The salvage value is 0. What is the weighted average cost for owning and operating the machine? Now, as you can see here, the maintenance cost rises each year. The second column is that of the maintenance cost. The maintenance cost in the first year is 0, in the second year it is 100, third year it is 200, so on. Now, let's calculate the discount factor for each other, which is each year, that is nothing but new r raised to r minus 1. Now, nu is nothing but 1 over 1 plus I, that is 1 over 1 plus 0.05, where 5% is nothing but your interest rate. So, for the first year, it's going to be 1, and the subsequent year, it's going to be the values shown 0.95, 0.90, 0.86, and 0.82. Now, the discounted cost is going to be the value of the maintenance cost multiplied by the discount. So, there we have it in the fourth column. Now, in the fifth column, we calculate the total discounted cost, which is going to be nothing but C plus summation of RR raised into mu R raised to R minus 1. So, as you can see here, it's nothing but it's C added to the fourth column. It is nothing but 500 added to the fourth column. After that, you need to remember one thing, that we also in the fifth column we have added the subsequent cells. That is, if it is 500, so it's 500 plus 95, that makes it 595. 595 plus 181, that makes it 766.64. 766.64 plus 259 makes it 1035.79, and 1035.79 plus 329 makes it 1364. So, this is the way we have calculated column number 5. Now, column number 6 is nothing but the cumulative discount rate, which is nothing but you add column number 3 cumulatively. 1 plus 0.95, that makes it 1.95, and 1.95 plus 0.90, that makes it 2.85, and so on. Now, we calculate the weighted average cost as per the formula given. So, what do we find here? We find here that in the third year, the weighted annual average cost is 271.6. Now, this is lesser than the maintenance cost in year 4, which is 300. Therefore, we have to replace the machine in year 3. Okay, as per the formula given in the previous slide. So, we have to replace this after 3 years. So, that's it. This is the way we calculate how to find the replacement year for a machine when you have a time value for money, or where you know that money, if invested, could earn you more money because market gives you interest on your investment. So, that was all, guys. Do like and subscribe my channel, and do share the link of this video if you feel that some of your friends might benefit from this. Goodbye, friends. Have a great day and have a great time.